Welcome to this video tutorial on how to use Clickteam Fusion to program a single-player Pong game. In this tutorial, you will learn how to easily program a single-player Pong game that features an intelligent computer opponent. I designed this tutorial for people who understand the basics of how to use Clickteam Fusion. If you are a complete beginner and want to understand the terminology that I use in this tutorial, check out some of the links that I have placed in the description below. I have divided this tutorial into sections. To skip to a section, just click on it. To shorten this tutorial and focus it on programming, I have already put the necessary objects. On the left side of the screen, I have placed an active object and named it Player Paddle, and on the right side of the screen, I have placed an active object and named it Computer Paddle. This small white square is an active object that I have named Ball, and this small red square is an active object that I have named Ball Trajectory. In the Computer Opponent Related Events section of this tutorial, I explain what the Ball Trajectory object is for. I have also created a counter called Player Score Counter and a counter called Computer Score Counter. These counters will be used to keep track of the player score and the computer's score. At the upper left corner of the frame, I have placed a string object and named it Player Score. This string object will be used to display the player's current score. As you can see in the Object Properties window, this string object contains 4 paragraphs. Each paragraph will correspond to a specific player score. At the upper right corner of the frame, I have placed a string object named Computer Score. This string object contains the same paragraphs as the player score string object. It will be used to display the computer's score. Finally, I have also placed 2 more string objects. The Win or Lose string object will display text that tells the player if he or she won or lost. As you can see, this string object contains 2 paragraphs. Paragraph 0 will be used if the player wins, and paragraph 1 will be used if the player loses. Note that this string object is set not to be visible when the frame starts. Positioned under the Win or Lose string object is a string object named Play Again or Exit. This string object will also be displayed when the player wins or loses. It will tell the player that he or she can press Escape to exit the game, or press the spacebar to play again. This string object is not visible when the frame starts. Before adding events, I will set up some of the objects by configuring their properties. First, I will set the Player Paddle object to Bouncing Ball Movement. Next, I will set the speed to 40 and uncheck Moving at Start. Now I will change the name of the Player Paddle's alterable value A to Movement Control. It is a good idea to rename your alterable values to keep things organized. I explain what this value is used for in the Paddle Movement Related Events section of this tutorial. To shorten the tutorial, I have already configured the Computer Paddle object. I configured it in the same way that I configured the Player Paddle object. I am also going to set the Ball object to Bouncing Ball Movement, and I'm going to set its speed to 20. The randomizer should be set to 0 so that the ball will bounce in a predictable way. I explain why the ball needs to bounce in a predictable way in the Computer Opponent Related Events section of this tutorial. Finally, I'm going to set the movement of the Ball Trajectory object to, you guessed it, Bouncing Ball Movement. The Ball Trajectory object needs to move at a high speed, so I'm going to set its speed to 250. That is the high speed that Fusion allows. Also, just like with the ball object, the randomizer of the ball trajectory object needs to be set to 0. I will now start programming the game. First, I will add events for the ball object. To keep things organized, I'm going to create a group called Ball for the events. I'm going to add 2 subgroups to the ball group. I will call the first subgroup Ball Movement, and the second subgroup will be called Ball Creation and Destruction. In the ball movement subgroup, I'm going to create a condition that checks if the ball is left the top or bottom of the frame. For the actions, I want the ball to bounce, and I want a sound effect to play. I am also going to create a condition that checks if the ball is collided with the player paddle or the computer paddle. When this occurs, I want the ball to bounce and I want a sound effect to play. Finally, to make the game more exciting, I want the speed of the ball to increase by 1 every 1 second. In the ball creation and destruction subgroup, I want the ball to be created in the center of the frame when the frame starts. The frame is 320 pixels wide by 200 pixels tall, so the ball will be in the center of the frame when it is created at an x-coordinate of 160, which is half of 320, and a y-coordinate of 100, which is half of 200. To detect if the computer has scored, I will create a condition that checks if the ball has exited the frame on the left. When this happens, I want to destroy the ball, create a new ball at the center of the frame, add 1 to the computer's score counter, and play a sound effect. To detect if the player has scored, I'm going to create a similar event. This time, however, I want to detect if the ball has exited the frame on the right. If it has exited the frame on the right, then I want to add 1 to the player's score counter. I will now add events to show the player's score and the computer's score. First, I will create a group called Display Scores. Now, in that group, I will create an always condition. I will then create an action that sets the player score string object's paragraph number to the player score counter plus 1. I will also create an action that sets the computer score string object's paragraph number to the computer score counter plus 1. Adding 1 is necessary because the counter object starts at the number 0, while string object's first paragraph starts at the number 1. We can make a string object's paragraph number match a counter object by just adding 1 to a counter object. Now I will add events that let the player restart or exit the game. I'm going to create a group called Restart and Exit. Next, when the escape key is pressed, I want the game to end. Finally, when the player presses the spacebar and the win or lose string is visible, I want the game to restart. The win or lose string will only be visible after the player has won or lost, so the player will only be able to reset the game at that point. This prevents the player from accidentally resetting the game while he or she is still playing it. I am now going to add events that specify what happens when either the player wins or the computer wins. I will call the group that I am creating Player or Computer Wins. To determine if the player has won, I will create a condition that checks if the player's score counter equals 3. When the counter equals 3, I want to destroy the player paddle, destroy the ball, destroy the computer paddle, make the win or lose string visible, and make the play again or exit string visible. When the computer score counter equals 3, I want the same things to happen. However, in addition to the same things happening, when the computer score counter equals 3, I want the win or lose string to be set to paragraph 2. Paragraph 2 informs the player that he or she has lost. Now I need to add some events to handle the player's input. First, I will create a group called Player Input. To stop the player paddle's movement when the player is not providing any input, I'm going to create a condition that checks for no player input. If there is no player input, then I want to set the player paddle's movement control value to 0. In the next tutorial section, I'm going to make an event that stops the player paddle's movement when its movement control value equals 0. Using values to control objects, rather than using player input to directly control them, is a good habit to get into. Doing so allows you to quickly make an object that can either be controlled by the player or by the computer. I will now make a condition that detects if the player is providing up input. If the player is providing up input, then I want to set the player paddle's movement control value to 1. In the next tutorial section, I will make an event that moves the player paddle up when its movement control value equals 1. Finally, I will make a condition that detects if the player is providing down input. If the player is providing down input, then I want to set the player paddle's movement control value to 2. In the next tutorial section, I will make an event that moves the player paddle down when its movement control value equals 2. I will now add paddle movement related events. I'm going to create events that tell the player paddle and the computer paddle to stop when their movement control value equals 0, move up when it equals 1, and move down when it equals 2. First, as you might have guessed, I will create a group called Paddle Movement. In this group, I will add a condition that checks if the player paddle object's movement control value equals 0. If it equals 0, I want to stop the paddle's movement. I will now add another condition that checks if the player paddle object's movement control value equals 1. If it equals 1, I want to set the paddle's direction to up and start its movement. Now I will add a condition that checks if the player paddle object's movement control value equals 2. If it equals 2, I want to set the paddle's direction to down and start its movement. Finally, to keep the paddle in the frame, I will add a condition that checks if the paddle has left the frame. I will then add an action that bounces the paddle if the condition is true. The computer paddle's movement events will be the same as the movement events for the player paddle. Note that in this situation I could have used a qualifier to reduce the number of events. I chose not to do this because I wanted the events to be easy to read. If you want to learn about qualifiers, check out the link in the video description below. I will now add events for the computer opponent. First, I'm going to create a group called Computer Opponent. Within this group, I'm going to create two subgroups. The first subgroup will be named Ball Trajectory. As for the second subgroup, I will call it Computer Opponent Input. In the Ball Trajectory subgroup, I'm going to create an event for the Ball Trajectory object. The computer opponent will use ball trajectory objects to react to the ball's future position. For this to work, both the ball trajectory object and the ball object must bounce in the same way. You should set the randomizer for both objects to 0 to make them bounce in the same way. To make this event, I will first create a condition that is true every 10/100ths of a second. Now I'm going to make an action that creates a ball trajectory object at the ball object's current position. Don't worry, because the condition is true only every 10/100ths of a second, the number of ball trajectory objects will not get too high. I'm also going to make an action that sets the direction of the created ball trajectory object to that of the ball object. I will now create an event that destroys the ball trajectory object when it leaves the left or right side of the frame. I will also create an event that makes the ball trajectory object bounce when it tries to leave the top or bottom of the frame. Finally, I will create an event that makes the ball trajectory object bounce when it collides with the player paddle object. In the computer opponent input subgroup, I will create an event that tells the computer paddle to move down when a ball trajectory object is underneath it. First, I'm going to create a condition that I want to be true only every 20/100ths of a second. Doing this will slow down the computer opponent's reaction time, making it easier for the player to win. I also only want the condition to be true if a ball trajectory object is greater than or equal to 290 pixels on the x-axis. Because 290 pixels is near the computer paddle's x-axis position, this condition will stop the computer paddle from reacting to ball trajectory objects that it cannot touch. The condition should also only be true if a ball trajectory object is greater than the y position of the computer paddle. For the actions, I will first add one that sets the movement control value of the computer paddle to 2. This will cause the computer paddle to move down when a ball trajectory object is underneath it. For the last action, I will destroy the ball trajectory object. This will ensure that the computer paddle does not react to ball trajectory objects that are greater than its x-axis position. In other words, the computer paddle will not respond to ball trajectory objects that are behind it. Now, to make the computer paddle move up when a ball trajectory object is above it, I'm going to create another, similar event. This event's condition, however, will check if a ball trajectory object has a y position that is less than that of the computer paddle, instead of greater than that of the computer paddle. For the first action, I will set the computer paddle's movement control value to 1. This will cause the computer paddle to move up when a ball trajectory object is above it. For the second action, I will destroy the ball trajectory object. Finally, to make the computer paddle stop moving when a ball trajectory object is near the paddle's center, I'm going to create one more event. Like I did when creating the previous events, I'm going to make a condition that checks for the ball trajectory object being greater than or equal to 290 pixels on the x-axis. I also want to check for the ball trajectory object being greater than the y position of the computer paddle, minus 20 pixels. And I want to check for the ball trajectory object being less than the y position of the computer paddle, plus 20 pixels. For the first action, I will set the computer paddle's movement control value to 0. This will make the computer paddle stop moving. For the second action, I will destroy the ball trajectory object. Note that this event must come after the previous two events so that it takes precedence over them. Now I'm going to test out the game to make sure everything works correctly. Typically, the red ball trajectory objects will be hidden. However, I'm leaving them on so you can see how the computer paddle reacts to them. As you can see, when I lose, the appropriate text is displayed. Also, when I win, the appropriate text is displayed. I hope you enjoyed this tutorial on how to use Clickteam Fusion to program a single-player Pong game. If you have any questions, don't hesitate to ask them in the comments section down below. Thanks for watching.